When you're ready, you may begin.
Okay, hello everyone, my name is Jenny, and today I'm going to talk about a case study that I have done on the 3D printed prosthetic hand and a 4-year-old baby with a congenital deformity of the hand. So probably most of us take having 2 arms and 2 legs for granted, but I just saw how hard life is for those with disability. I still remember once I met a girl with congenital missing at a hospital, and she told me that she hoped one day to be treated as a normal people, not an outcast seeking for others' compassion. She was disappointed with life. I couldn't help feeling helpless and depressed, seeing her destroyed by physical and mental suffering because of this disability. I understood that disability not only brings people inconvenience in life, but also give them a feeling of inferiority. And according to a cross-sectional study, poverty and young disability in China result from a large nationwide survey. There's a strong correlation between poverty and prevalence of the disability among children in China. As you can see at here, youngs living in poor households were 3.84 times more likely to be with disability than those living in affluent household. And although highly bionic prosthetic limbs are available on the market, people still cannot access expensive bionic prosthetic hands. And life was especially hard for low-income families with disabled children because children have to go through a constant cycle of prosthesis replacement as they grow up. And a national wide the 2001 nationwide sample survey even reveals that some families in China even abandoned their disabled children as they could no longer afford the cost of treatment. And here is for those people from second tier city, which are those low-income families, they lack of access to expensive bionics prosthetic hands because of the complexity, affordability, and expertise requirements required in the fabrication process. So they are not readily available to patients in those developing cities. And however, it is very crucial to explore some implementable solution to alleviate the financial burden of disabled people. And last year, I participated in a Shanghai Science and Technology Carnival, and I met an engineer working at Farm Lab, and he told me that 3D printing has the potential to create an inexpensive and comfortable prosthesis for people who have lost their hands. So I come up with an idea to examine the efficacy of 3D printed prosthetic hands for children with congenital deformity hands in terms of basic grasping toys ability. And I found out an article that summarized the research that reported human trials of 3-dimensional printed upper limbs prosthesis. Like after removing the duplicates, there are 321 records were identified, and all of those only 8 of them, 8 of those records meet the inclusion criteria, which are the criteria that they will examine the relevance, language, and whether if the paper is peer reviewed or not. And among all of the studies that met the inclusion criteria were case study. So I'm also doing a case study. And another study which is open source, and basically it developed a robotic below elbow prosthesis for an amputee who is a female, and the efficacy of this design prosthetic hands is violated through different experimental method, and it's involving grasping of daily life objects and execution of daily life activity. And the daily life activity mentioned here is something like to serve water or to stir the water inside the glass with a spoon. And it turns out that these prosthetic hands have allows individual thumb to move independently, and the thumb configuration can adjust by a lockable mechanism. And I found out this method is quite effectively in measure the efficacy of the grasping ability of prosthetic hands. And so the 3D printing prosthetic hands in my research typically refers to those comparative affordable 3D printing prosthetic hands. And the gap in my research, gap of the research are the targeted population. Like almost all of the studies are limited to the patient with 4 hand amputation. Like there almost no study have done on the patient with a congenital deformity of the hand. And the focus of the study is also quite different. Like most of evaluation only focus on the functionality of prosthetic hands. There were no control group. Like they didn't compare the grasping ability of original hand and prosthetics. And also, I'm going to focus on the grasping ability of grasping toys. And here comes to my research question, which is the efficacy of 3D printing prosthetic hands for children with congenital deformity hands in terms of basic grasping toys ability. And the goal of my research is to design and test an inexpensive, wise-powered 3D printed prosthetics that can enable children to play toys. And also, I will evaluate the efficiency, and grasping ability based on 2 assessments, which are power and precision. And I'm going to compare and contrast the playing toys with and without prosthetic hands. And here comes to my research design. So firstly, in order to further narrow down my research method, I look at the result from error analysis of FDM fabricated medical replica. So this research basically shows that FDM present a similar dimensional error with other expensive 3D printing technologies, and the relative difference was merely 1.96%. So this means that I would choose FDM over all the other advanced 3D printing technology because FDM is quite affordable, and there's no big difference between very expensive technology and this affordable technology. And so basically FDM refers to those 3D printer that works by heating the solid plastic material and melting it and extruding it from a nozzle. The nozzle will move in both X, Y, Z directions by a numerically controlled mechanism. And this will add successive layers of material to build a 3D object. So the technique I'm using, the ethical approval was obtained for this study at the IBR, and I have clearly informed participants, other sponsors, the risk, benefits, purpose, and of these studies. And I also informed that it is up to them to decide whether or not to take part in this study. And I also got permission from the other sponsor of participants. Furthermore, a written informed consent was obtained for patients' experimental information and images to be used in a publication, but I will keep his identity confidential. So here is the basic information of my patient. The participant is a 3-year-old boy who is living in Tianjin, which is a second-tier city. And the patient experienced finger deformities that are present at birth. That is underdeveloped of 4 fingers of the left hand and the missing little finger. So I customized a device to the patient's anatomy. Firstly, I sketched the overall structure. So the basic mechanical structure is combined to draw a brief diagram of the kinematic mechanism of the prosthetic hands. And I want to, and the movement is done by simple string traction structure. And this structure is maintained, sustained by a galvanic wire. So when the patient bends its elbow, the fingers will bend as well, enable prosthetic hand to grasp some objects. However, the degree of freedom is 2, so this will lack some grasp strength. And then I used the Inventor software for 3D modeling of the shape of prosthetic hands. So the initial design were based on dimension drawings of the patient hands, followed by hand molds and 3D scans. And I draw the outer contour of the palm and the edge of the inner cavity according to the scale. So I basically modeling the general structure of the palm to the curve design, to the specific parts and edge, and the corners are polished. And finally, I use the Ultimator Cura to do the 3D slicing. So this enables to breaking down a design into several layers. And then it can deposit one by one on each other during the printing process. And then I send the STL file format into the FDM printer and finally print it out. And then here is the final product. As you can see, so this is basically working by bending your elbow. So the 3D print, like those 3D printing is comparatively affordable because it only costs 300 RMB for one 3D printed prosthetic hand produced by a rapid prototyping. And the above experience also shows this type of prosthetic has the potential to substitute expensive mechanical bionics due to shorter fabrication time, lower cost, and low technical expertise requirements. And here comes the experiment. So the efficacy of the proposed design is validated through different experimental methods. So firstly, they will pick out 8 things that are commonly used by the baby at home. And baby will try to grasp the object in sequence without help of prosthetic hands at first to see if baby can hold them for 10 seconds. Then the baby can put on the prosthetic hands and then try to grasp the same object for another 10 seconds. And the process was repeated 3 times. And here is the measurement. The graphs were divided into power, precision, and grasp. And there were 5 objects that require processive grasp, and another one required grip strength. And the stability of grasp.
Jenny, I want to give you a 4-minute time reminder.
Okay, so the stability of grasp is based on the duration of time. And here is the result. So basically, most active, the above, so the one without prosthetic hands have a better performance on the position. As you can see it here, 4 out of 5 numbers of toys can be stably grasped by the original hand of that boy. And prosthetic hands can have a better is effectively in grip strength. So to calculate the average stability, as you can see it here, the average stability without a prosthetic hand is 5.45, and the average stability of with prosthetic hands is 6.65, which is 22.1% greater than the one that without prosthetic hands. And here comes the conclusion and analyze. The feedback from the patient indicate that the main advantage of the device were its compactness, lightweight, and super donning and doffing. So this is a great way for prosthetic are a great way to help children hold large cylinders, and in contrast for small or thin objects, he can do it by himself by cleaving. However, this also has many weaknesses such as lack of touching sensation. And in conclusion, despite low grasp precision, the device function was sufficient for this patient's case, as its vital need is to have a stable grasp of toys. And the implication of this is this design can alleviate the financial burden for families, and this can also have this is also a more appropriate prosthetics solution for a low-income family. And the limitation for this is the number of toys evaluated. There are 2 small range of toys. So, and also because this is a case study, so it doesn't really cannot generalize. And the material and the future study, this could probably be overcome by using alternative material for the finger and thicker galvanic wire, and increasing the friction between interlocking finger part. And thank you for listening.
Ms. Jennings, would you go?
Yes, great job, Jenny. I'm quite impressed. All right, my question to you is, how did you determine which results generated by your research method were most important in informing your new understanding?
I believe the one that talks about the average stability is the most important result, since it supports my hypothesis that this is this is a better solution for low-income family, and this can help children to have a stable grants of toys.
Okay,
thank you.
Mr. And we just ran out of time. Okay, I'm sorry, Jenny, I can't ask these other two questions. Your presentation was amazing. It was a great job. Mr. Kaplan?
Yes, absolutely. I was all set to ask a question, but I won't.
All right, Jenny,